Imagine a world where mountains of waste are transformed into a treasure trove of resources. Today, let's take a look at a truly innovative technology, low-temperature pyrolysis. Do you think burning is the only way to get rid of trash? There is a smarter, cleaner, and more efficient way. That way is low-temperature pyrolysis. By applying heat to waste in an environment with little to no oxygen, we decompose it at a molecular level. It's not about burning, it's about breaking the molecular chains. This is fundamentally different from traditional incineration. The difference is clear when we look at the facts. First, there's the absence of oxygen. Think of it as cooking in a vacuum. Without oxygen, the chemical reaction known as combustion simply cannot occur. Second, there's the temperature. While traditional incinerators burn waste at over 800 degrees Celsius, pyrolysis operates at much milder temperatures. No burning and lower temperatures. These two conditions are the magic keys to drastically suppressing the generation of harmful substances like dioxins. The process is incredibly simple. First, waste, such as plastics or food scraps, is fed into the system. Next, as heat is applied within an airtight, oxygen-free chamber, the molecular bonds begin to snap one by one. In an instant, the waste is reborn into three distinct, high-value resources. The first is char. It can be used as a solid fuel, but more interestingly, it's an excellent soil conditioner. Adding it to the earth improves water and nutrient retention, helping to create rich, fertile soil. The second is biooil. With a bit of refining, it can be used as a source of energy, much like diesel fuel. The third is syngas. This flammable gas is recycled as the very heat source used to power the pyrolysis system itself. This creates a highly efficient, self-sustaining loop that disposes of waste without needing external energy. The true impact of this technology on our society and environment starts here. There are three major advantages. Significant CO2 reduction. Since there is no direct combustion, it directly contributes to global warming prevention. Carbon credit creation. I'll explain this in more detail in a moment. Ease of implementation. Unlike massive incineration plants, these units are compact. This makes them a realistic option for factories or areas where building a large-scale facility was previously impossible. Regarding the carbon credits I mentioned, the secret lies in carbon sequestration. Instead of burning the carbon in waste and releasing it into the atmosphere as CO2, we lock it away in a stable, solid form, char. This act of sequestering carbon is just as valuable as removing CO2 from the air. It is recognized as a significant environmental contribution and carries economic value through the carbon credit market. This system proves its worth in fields where traditional processing is too costly or difficult. Take waste plastics, for example. What used to be buried or burned can now be returned to the economy as valuable char and oil. Sludge and food waste, which are difficult to process due to high moisture content, can be drastically reduced in volume and turned into fertilizer or fuel. Even medical waste, which requires careful handling, can be safely sterilized and neutralized at high temperatures. It is truly a reliable savior for the waste our society has struggled to manage. A magical steaming machine that turns trash into resources. This phrase perfectly captures the potential of this system. We aren't just making trash disappear, we are giving it a new life. This is a historic turning point where waste management shifts from being an environmental burden to an environmental contribution. What kind of future can we build with this technology? Let's think about it together.